Hi everyone, thanks to watch this video. Um, my name is Henrik Rexed. I'm the technical evangelist at NeoLoad. Today I'm very glad to present the session, which is continuous performance testing with NeoLoad. So we'll see the different challenges in implementing performance testing in an agile environment and try to figure out what are the best practices and automation tips to allow you to start testing as early as possible. So the agenda is first we will see the challenges related to performance testing in an agile environment, understand why it's a problem, and then we will move on to the best practices, how we can implement it, and how we can automate it. I will briefly present the NeoLoad Agile architecture, the different components that we have here in our solution, and which fits very well in an Agile environment. And last, we will do a demonstration with the different components involved, so we can see the value of them and why they are interesting, especially in an Agile development lifecycle. All right, so let's start. Let's start with the challenges. And the first element, let's understand the main issue. So we have basically two dimensions, the theory and the practice. In theory, if you look at how Agile is working, we are iterating. So we have a working system, we are having different iterations, so we have to test those iterations one by one. And on each sprint, we have a very good understanding on what's inside this iteration. So we should basically test what is needed. So we know what we have to test, so we can easily implement it. The performance engineer will be working on the whole project, so on every iteration. So that's works also very fine, testing everything. And we will have to adjust the requirements depending on the new functionality. So we have a new functionality, we will change the requirements and test it on a daily basis. So that is the theory. And now in practice, it's a total nightmare. We have a lot of iteration, a lot of sprint. Each sprint or each iteration means we have very short testing cycles. So we are not able to implement the old performance testing process. And most of the time we only implement performance on specific iterations such as hardening iteration or technical depth. We are making priority in functional testing. In fact, it makes sense. If I'm putting all the effort and performance but not on functional, then maybe I have a performance application, but which is not doing what is not expected. So I rather put all the effort again on functional, but find a way how to implement performance testing. Second aspect is that many organizations have skill centers, center of excellence, or performance team handling or addressing the performance testing for many projects. And if all the projects are in Agile and they have to implement the whole performance process or all of those iteration and those projects, then it means we will explode the workload within those teams. And they have to increase the number of persons, and at a certain moment, it will be a bottleneck. It will struggle because we'll try very hard to scale and manage those teams. The second aspect, or second challenge, is automation. The setup is quite complex. So I'm not referring to load and performance testing solutions, those are quite easy to deploy and install. But the environment, you have a continuous integration server or something else. We have a source control. You need to build up the application, deploy it, and you want to include performance in this environment. So the environment is changing quite a lot. It's going to be quite a challenge, in fact, to include performance in this process. Second aspect is when it comes to functional testing, you define an issue, pass it fails, you get the screenshot or results of the problem, you send it back to the developers so you can reproduce the problem and correct that. But here in performance, one performance issue behind it could many problems. Could be part of the code or several part of the code, which brings that performance problem. Could be also the database, could be the environment. There's many things, many lists of things. And the results itself are complex. You need to correlate the architecture, load, and to reproduce the tests. I mean, if I do it on my environment and I ask the performance engineer and the developers to reproduce it, then if he doesn't have the same data set, the same database, or the same release of the application, then it's going to be a challenge to reproduce it. So it's very hard to compare two test results. In the other aspects, we are iterating, we are constantly changing the application, and we deliver pieces of applications. So the interface, the application is changing, constantly changing. So we will have lots of maintenance on our load testing scenarios. The other aspects regarding automation is when should I automate? So we need to know the system very well before starting automating, before having a meaningful automation. So there are two kinds of application. The first one is a new system. Automating there, in that case, the overhead will be quite high because we don't know how it behaves. So first we need maybe to have a baseline, see how the application behaves with load. Maybe also fine-tune the environment. Maybe the environment has not been sized or configured to our application. So we need to explore and see how it's going to behave. Once we have a good idea, then we could start automating. So the system has been tested again and again. We can invest in automation. The new updates on the application will impact less our scenarios. So we have less maintenance in the automation. The new system will cost more because we need to maintain those scenarios. And last is API. Could be REST, could be SOAP, could be Asian web services, it could be GMS, it could be MQMS. I don't know. There is many ways to implement services. And this is simply you send an input, send variables into a method that sends back an output. So the interface of the API is not changing. It's quite stable on the very early stage. So we could start testing those API without having the need to maintain often our scenarios. So we have two dimension, new application. So we have to explore, see how it goes, how it behaves, get the baseline. And we have a well-known application. Well, we want to know if we have any regressions. See if the updates, the new piece of code that have been added, doesn't impact performance regarding the last build, or iteration. Another aspect is how we are delivering our performance requirements. Basically, if you take the way we're used to do performance, we're having a user journey on the application. And this user journey here is utilizing the login page, search box, many aspects of the app. So behind this, there are many components or area of the project involved in this user journey. So we are spanning the load on the whole project, which means we cannot start testing if we don't have everything assembled. So that's why we are still waiting for an assembled application to start testing. The other aspect is the requirements. We're defining performance requirements depending on constraints. Those constraints are related to user stories, or we're defining SLAs depending on business cases. But again, behind that business step, there are many components involved, which means I'm not able to validate the SLA if I don't have the assembled application. So the way we are defining our requirements doesn't fit in an agile environment. So the challenge, we are having trouble to automate because the setup is complex. To reproduce performance issue is quite a challenge. We, depending on if it's a new application or we have already tested, the automation could cost quite a lot. And the way we are defining our requirements is not appropriated for Agile. So let's see the best practices now. We have to test early. This is not new. We know it, for everyone has agreed with this, but it rarely happens in practice. Because we don't have the workload, the budget, planning to implement load testing. And we need to have a more agile approach where the requirements of performance change depending on the content of sprints. We need to make performance everyone's job, where performance is one of the KPI that you need to follow from the beginning of the project to the end of the project. So the performance strategy will be built from the beginning, and we will make sure that every sprint, every build we're doing has good performance feedback. And of course, when I have assembled application, we'll test as well. So to do that, we need to change mentality. We used to do late record playback performance testing, waiting for an assembled application. We need to move to an early performance engineering, where the performance engineer will be involved at an early stage, defining a performance strategy for the beginning and the end of the project. We were defining SLAs on business steps, business process. We need to move this to component level requirements. So the record playback approach here is going to move to a more programming, generate load and steps. So we were testing black boxes where we didn't really know what were inside that box. But now we need to have a better understanding of what's inside the box, what's involved in the box to start testing it, so that we will have more gray box testing. Unit performance testing or component testing is the key. So it's not a standard practice. We are referring to user journey here. We need to transform our user journey into components to allow us to start testing as early as possible. We cannot afford to wait until we have an assembled application. Why are functional testing started early? And why we are not doing it? Because we are still pointing to a user journey involving many components behind it. So let's transform our user journey on components and see which components need to be tested one by one. So we could test any part of the system. The main advantage is the test case. The design is simple. A couple of data sets, and that's it. Many people says, my application is monolithic, so I'm not able to test one of the layer without this layer because it doesn't make sense. That's why there are some methodologies such as test-driven development that will make the answer. We can test as early as possible one of the component by testing the services. Last aspect is the third-party components. We are often having a third-party component for the banking systems or for the prices or the exchange rates or whatever it is. Why do I not test that component alone? To make sure that it's not a bottleneck. I cannot afford to wait until the very last mile of the project and see that my bottleneck is not my code, but the third-party component. So let's test it to, like a component itself. The other aspect is single user performance testing. We are not doing it quite often because due to the time and the pressure and planning. But if one single user doing manual testing on the application is finding that the performance is poor, is not respecting, is not acceptable, then with multiple users, it should be the same case or worse. Don't start testing if at least with one user there is already a problem. And the advantage with one single user, you can implement profiling or deep dive analysis tools. So we are gathering a lot of data, a lot of helpful information to correct and resolve that problem before start implementing load testing. To automate, there are a few tips around that. The first one is continuous integration. So we have to plug our performance testing solution with our continuous integration server. So we can trigger the test through command line, for example, within our continuous integration server. So we have to change our building process by adding another step where it will trigger a load test. So it could be after the unit tests or smoke tests, you can include the performance testing. You need to set up SLAs. Without SLAs, you won't be able to define if performance testing has pass or fail on that automated test. So performance needs to be treated exactly like unit tests by having a G-unit report, for example. We need to have a dashboard displaying our SLAs. And it will allow us, testers and developers, to see the status of the tests, the quality of the performance between each build. We need to be able to compare each build and see if there is any regression between one build and another one in terms of performance. Don't implement the wall performance battle on each build. It doesn't make sense. We need to define the complexity of the test depending on the size of the build. If we have continuous integration build during daily build, then I will do some performance smoke tests to make sure that the environment's working well. During nightly build, I will probably implement load testing on the main components. At the end of the iteration, I will do more stress testing, limit tests, soak tests, and so on. Of course, I have more assemble application. I will start doing end-to-end testing by validating that the application works fine once we have an application integrated with our the different systems involved in my environment. Load testing in production is a hot topic at the moment, but don't do this with automation. We cannot afford the load test to crash our production environment. We need to be at least in front of a screen to stop the test if needed. So, we know now the best practices. The key element is component testing, allowing us to test as early as possible. Implement component testing between each build to validate that each component are stable and performant, and then test the assemble application to see if those components are also stable and performant when they're working together. Now let's see NeoLoad's Agile architecture. So the first thing is we are working in team. We are collaborating here in our project. We have probably the developers creating test cases on components. The performance expert or specialist or performance of the team will be more focused on end-to-end testing to implement the test for the assemble application. So there will be many test cases for load testing on components, on components, on graphical. So we need to be able to point everybody pointing to the same release of the application, to the same project. So we could automate and point always to the same application. So we need to collaborate, working together on the same project and share best practices and SLAs on the same project. Team server, the NeoTest team server allow you to do that. So you will share your project, scenarios, user profile, test results within your project. You'll be able, like source control, to create versions, to check in, check out, commit, create branches. Through the administration portal, you'll be able to give rights to the users. Some user will be allowed to update the project. Others only look at the results, and that's it. So you will be able to have people designing, people running tests, and people analyzing from their side and pointing to always to the same project. So we will collaborate on performance. Second aspect is the license. I will probably have my continuous integration server running tests doing nightly builds. So he will have to have a license. He will pick one of the license. In parallel, I will have maybe some other tests on other part of the piece of the application. So they need also a license. So I will need the way. I cannot offer to have several licenses within my organization because the investment will be too high. So here I need to have a shared license, allowing me to split my license in several small licenses. So I can have several tests running, and when a test is finished, it could simply release the license. So someone else could pick a license, another piece of license. So the shared license is like a pool of users that you buy, and you can split as many times as you want within your project. You will be able to manage the rights through the NeoTest server and define the maximum number of users allowed per users or per group of users. So the architecture, simple. You have a source control, you have a team server, so the developers make some change on the code, maybe create this test case on the component testing, publish that on the team server, NeoTest team server. The tester maybe prepare some end-to-end testing, do the same, commit the changes. And then you have a continuous integration server, of course. So if there is a build, so the continuous integration server will get the latest release of the app, build the app, deploy the app, start unit testing, smoke testing, and then you have load testing. So he will trigger tests on the NeoLoad controller. The controller will run the test, of course, and once the test is finished, you will publish the report on the continuous integration server and generate a dashboard. So every member of the project can see at any time the status on performance and trending performance between each build. So let's see the demonstration. So here in my demonstration, everything will be related to one application called Ushaidi. It's a non-profit organization that offers to the community the way to exchange weather incidents around the globe. So we have two types of clients: browser-based users and mobile users. The advantage of this project is it's involving APIs behind it, so I'm able to implement component testing. And of course, afterward, I will have the end-to-end testing. And once I have a more assembled application, representative environment, I could also validate the performance, the user experience afterward. So here, the architecture is based on Apache, PHP, MySQL. So here in my project, I have several tools. NeoLoad to generate the load, of course, on component level or user end-to-end testing. And then when you have more assembled application, I need to measure the end user experience. And for that, I will use two tools: web page tests. I will measure the user experience on the browser-based testing. And I will have Perfecto Mobile that will measure the user experience on strategic mobile devices. Around that, I have, of course, other components, the NeoTest team server that will allow me to publish my project, Jenkins to use for the continuous integration that will trigger load testing. So let's first look at Jenkins. So here is, of course, Ushaidi. So this is the assembled releases. We have a weather map, the map of the globe showing all the incidents. And of course, I can create a report and look at the different reports. Here we have Jenkins here behind it. Jenkins is triggering tests on NeoLoad. Of course, I will show you NeoLoad afterward on a different element that we have in this project. And Jenkins here is showing me that everything is sunny. Everything is working fine within Jenkins. So here, once Jenkins been quite slow here, but once I will have access to here the dashboards of Jenkins, here I'm able to have a clear status of the performance between each build. So here you can see that each build here, I'm running load tests, and I'm plotting here the average response times. So I can see that between build 34 and build 35, we have made a lot of progress in terms of response times. We have decreased almost 3 seconds in the response times. The error rate is stable, no errors, so I'm quite happy with this. So it means everything in terms of functional works fine, and no HTTP 500 or 400. Underneath we have the SLAs, and we can see the number of SLAs in red that has been failed and number of SLAs in blue that has been passed. So you can see that since build 34, we made a lot of progress in respecting our SLAs. Here at the left, I can see all the builds that have been launched on my application. So if I click on one of the builds, I will have access to the details of that specific build. So I can see the output of Jenkins, but also I can have the performance testing results. So if I click on it, I can see the report of NeoLoad and see what were the SLAs, the monitoring, and so on that we have seen and detect in NeoLoad. So that is very important, especially when you're doing nightly build and automate your load testing within your Agile environment. Second aspect is the team server. So here behind this, I have a shared license, and I'm defining different roles within my organization. So I have performance engineers and automation tools, so such as Jenkins, in fact. So here, first thing is a user. So you can see that we have a Jenkins user and myself. And the Jenkins user is continuous integration server role, and here myself, I'm a performance engineer. So here you define the user right and how they're organizing within the roles. Each roles you will allow to give rights afterward on the project itself. You can see here we have Ushaidi project, and I can give permission. There are two roles at the moment. The performance engineer are able to read and write, and continuous integration also can read and write. Licenses. Here I got my shared license with 1,000 user, and I also able to give permission on this. So the performance engineer here is able to retrieve 500 users during 5 days, because I know that the ordering iteration takes more time to implement the different tests that we have in our performance strategy. The continuous integration server is dedicated for Jenkins that will retrieve one license for a nightly build tests. And the test, I know that it will be less than 7 hours. So after 7 hours, he will simply release the license. Okay, so that's basically is how we manage the rights on our licenses and on the projects directly on the administration of the team server. So let's look at NeoLoad. So let's open our project, which is here. So it's one of the latest projects. By opening the project, we'll have a small detail here at the top. It shows that it's a local release of my server. So I could also force to update the project from the collaborative server. So I will do it right away. But here you can see that here this is a link to my team server. So I know it's a shared project. So let's first update that project. So I'm going to retrieve the different updates that has been done by other colleagues on my project. So everything has been updated. So now I can start doing any updates on my project. So here, before we do any updates, of course, we have a couple of things. We have the desktop browser-based testing, which is dedicated on involving the graphical user interface. So we have this user journey, which is already correlated and going on the publishing report. And then we have the iPhone user, which is only involving API. So here, this will be utilizing on between each build. Of course, those scenarios are all correlated. They are pointing to data sets. So I have a data set for the cities with different coordinates of cities. I have different kind of title, description for the incidents that I'm sending to the application. So I'm sure that everything that I'm sending is representative to the production. With this, during our harder iteration or more end of iteration tests, end of sprints, I have two users, Perfecto Mobile, that will allow me to measure the user experience on my mobile native application. And last is web page tests, which will also do the same, but here with involving web page tests to make sure that on specific browsers my user experience is acceptable. I have defined populations, so I've defined different populations available. So here I will use I won't go here on those aspects. And of course, I have defined some monitoring on the architecture to make sure that the architecture is stable and available. I'm not going to run a test here, but let's see a test. So I'm going to retrieve one of the test results here available on my team server. So I have two tests. Let's pick this one. Oh, it's already on my project. In fact, it's local. So I have the two tests retrieved on my project here, bad and good. So it allows me to look at the results here, simply like load tests, create my own dash report, showing the, for example, the response times and monitoring exactly like we used to do with load testing, performance testing, and combining data from the user experience. So here I'm having homepage, and I want to compare it with the homepage of web page test. So I can easily see if the user experience is acceptable from web page test perspective. So I'm not going to run the test because it's not the matter. The idea was to present the different components that we have in NeoLoad, and that was the main purpose. So you can see that you could trigger tests from Jenkins, publish everything on a team server, and allow you to automate easily your performance testing within your project. That's it. Thanks for your time. I hope it was interesting content for you. I'll leave my contact details, henrytraxted@neotis.com. So if you have any question, anything, I'll be very glad to answer to your question because it's a pre-recorded webinar. Unfortunately, I'm not able to answer to your question directly in live, but I hope that you have questions and I will be pleased to answer them. Thanks for your time and have a nice day. Bye.